So let's continue with our project, and in this video we are going to create the player movement script. First, let's delete the tank game object, and next let's create a new folder in the project panel to hold all of our scripts. We can call this scripts, and inside the scripts folder let's create a new subfolder called transform, and this folder will hold all of the scripts that's related to manipulating transform. And inside this folder, let's create a new C# script, and we can call this player movement. But before we work on the player movement script, let's set up the player plane game object structure. In the hierarchy panel, let's create an empty game object, and we need to reset the transform value and rename this empty game object to player. And we need to also add a box collider to this empty game object and also a rigid body. But since we are not going to use the dynamics properties, we can disable the use gravity and check the is kinematic option. We need to do this so this object can listen for collision or trigger. And then let's parent the plane A model into the player empty game object. So I'm going to drag the plane A model to be the child of the player empty game object and move it slightly forward, so the model are positioned in the middle relative to the player game object. And here, if you look at the X rotation of the 3D model, it is rotated. Usually, when a model exports from Blender, we'll have this issue. And to compensate this, we can create another empty child on the player game object. Let's call this visual, because we are going to put all of the visual model as the child of this empty. So just drag plane A model to be the child of this visual game object. Now, to emphasize banking motion, we can just rotate the local z-axis of this visual game object. And now with this setup, save the scene and let's attach the player movement script onto the player game object. And then let's also open the script. Okay, now the script is open. Let's create a couple of variables first. First, we need to create a float variable that is public. A float is a floating point number, which means it is a number that has a decimal place. An integer is a number without a decimal point. And let's call this float variable speed and set its default value to 5. And in C#, float numbers are usually denoted by F character. And we also need to create another float variable called banking value and set its value to 90, but later we can change this in the inspector. And the next variable we need to create is a private variable with type of camera. And let's just call this cam. And we also need to create a private float variable called distance to hold the distance value between camera and the player. We also need to create a couple private vector 3 variable. The first one will be the velocity, and the second one will be the last position. And this is for calculating the velocity later. And the third one will be the rotation, and then touch pause, and the last one will be screen to roll. And we also need another public variable type of transform called visual child for holding the 3D model reference so we can manipulate its transform. And inside the start method, we are going to initialize a couple of things. The first, we are going to grab the camera into the cam variable by using the camera class and accessing its main property. So this is basically to get the first enabled camera tagged with main camera. And this is why we have set the first camera tag to main camera and the second one to untag. So we will be able to grab the air object camera. I forgot one thing, but we need to add another private variable type of rigid body. So let's just create one and call it myRB. And let's grab rigid body reference by using the getComponent method and pass it to the myRB variable on start. Basically, getComponent method is used if we need to grab a certain component in the same game object where the script is attached to. And this is called caching the component into variable. So whenever we need access to the rigid body component from a script, we can just access this myRB variable. And then we need to also get the distance of the camera to the player and pass it to the distance variable. And to calculate the distance, we can subtract the camera position with the player position. So let's get the camera position by accessing the cam variable .transform.position and subtract it with transform.position, which is the player position. And because the distance variable is a float and this is a vector calculation, let's grab the y component from this vector calculation. And why are we getting the y values? Because as you can see here in the scene, the y component is the distance due to the camera positioning. And here if we select the player game object, you can see the y value is 0. And if we select the camera again, the y value is 35. So we can agree that y delta can be treated as the distance. And inside the update, let's set the velocity to the current position but subtracted with the last position. And let's execute a method called move. But we are going to create this method in a moment. And then let's store the transform.position value into the last position variable. So we need to grab the last position for calculating the velocity in the next frame by getting the position differences. And now let's create the move method. So first, we need to get the mouse position. And the mouse position will be on the same plane of the camera. But we are going to change the z value to the distance value between the camera and the player. So we will get mouse or touch position aligned to the player plane. So let's set the touch position variable value to the input.mousePosition and then override the z values with the distance variable. Some of you may ask, why are we using the z component instead of y? So here in the scene, if we select the camera and then if we change the coordinate or gizmo from global to local, the distance is represented by the z-axis. And because input.mousePosition are going to be aligned with the camera plane, we need the distance between camera and the player so we can project the mouse position to the world position that aligns with the player. So that is why we are overwriting the z component of the touch position variable with the distance value. And next, we need to set up the screen to world variable by converting the touch position into a world position using the camera. And we can use screen to world point method and pass the touch position as the argument. Now we are using mouse position, but later we are going to change this into a real touch position. Next, we want to create a temporary vector3 variable called movement, and then we want to interpolate vector3 values using lerp from the current transform.position to the new screen to world position, which is going to be the input position in the world. And for the third argument, which is the t or interpolation value, we want to pass the speed variable, but since we are running this inside the update, we need to multiply the speed with time.delta time. And this is to make sure, so the speed will be time dependent instead of frame dependent. And it will be the same regardless of the FPS performance on different devices. And now we are going to apply the movement value by accessing myRB variable, and we can access the move position method from rigid body component and then pass the interpolated vector, which is the movement variable, as the method argument. And now let's test this script. Back to Unity, the script is currently compiling. And here, as you can see, we have exposed public variables in the inspector. But I'm not going to change a thing for now. Let's press play. And now, as you can see, the player shape are following the mouse position with a slight delay or damping. It's working, but now we need to add the banking effects.
It's Romy from the future here. I just want to let you know, if you are using Unity 2019 or above, you need to change a couple of settings to make the player movement work. First, we need to go to the project settings. Under the physics, make sure you check the auto sync transform. And we need to modify the script a bit. Here, in the lerp, code, we need to change the initial position, which is the transform position, instead using the rigid body variable dot position, and save this. And now this should fix the issue where user cannot move the plane on newer Unity version.
So let's drag the child visual game object into the visual child slot in the inspector. And then we need to modify its transform. So next we need to modify the rotation variable, and we need to only modify the Z rotation value. So let's just set this to the velocity.x value and multiply it with the banking value. And then let's apply this rotation. So using the myRB variable, we can access move rotation method, and this asks for a quaternion as the parameter. So let's set up a new quaternion value using its class, then add .Euler and pass the rotation. And why do we modify the Z rotation? Because if you see here in the editor and select the visual game object, if we rotate on the Z axis, you can see the ship is banking, like if it's moving sideways. And this code is going to do just that. And here only the X value from velocity that will drive the banking. And then we convert the rotation value into a quaternion and pass it into the move rotation method of the rigid body. Okay, so let's save the script and head back to Unity to test this. And as you can see, there is a slight banking motion. So let's increase the banking value and make it twice from the previous value. And let's test this again. Now we can see it better, but the banking is inverted. We can easily fix this. Just add a negative sign on the velocity.x value and the rotation will be inverted. So let's test this again. It is now banking correctly, but the movement is a bit jittery. So we need to also fix this. Since we are modifying the rigid body in the update method, it is recommended to do this in the fixed update instead. So I'm going to change the update into fixed update. And we also need to change the multiplier of the speed from time.delta_time and use time.fixed_delta_time instead. Time.delta_time is the time difference between frame in an update cycle, and time.fixed_delta_time is also time difference but between physics step inside Unity. Save the script and let's test this again. And now we have a much smoother movement, and the banking rotation is also very smooth. So this concludes the player movement lesson.